All right, so we're going to talk about lemniscates and roses today. Again, there's a cosine and a sine lemniscate, and there's a cosine and a sine rose. The lemniscates, I would say, are pretty easy to identify from their equation because they're the only ones that start with r squared. All the other ones started with r, except for the one that started with theta, right? So everything else starts with r. So as soon as you see that r squared, you should automatically be like, okay, this is a lemniscate, okay, because that's the only one. Okay, so there's no reason to get those ones mixed up. The picture of the lemniscate is kind of like a figure 8, or I have some people call it an infinity symbol, because it does look kind of like infinity. For cosine, it's going to have x-axis symmetry, which means this is just a figure 8 on its side over the x-axis. Let's do an example. So let's say we asked you to graph r squared equals 16 cosine 2 theta. 16 cosine 2 theta. Okay, so that's the right pattern. It's r squared equals a squared cosine of 2 theta. Now for a lemniscate, it's always going to be 2 theta. Okay, so that's different versus the ones we saw yesterday. They were all just thetas. Okay, so this one is going to have a 2 theta in there, and it's going to have the r squared. All right, so when I start here, 16 corresponds with a squared, right? So a squared equals 16, which means a equals 4. In this equation, a represents the length of the petal. We call those the petals because kind of like a flower has petals or leaves have petals. That's what that looks like. So those are the petals. Okay, so let's see how this graph looks. You're going to start it at the pole. It's going to have x-axis symmetry, so it's going to go along the x-axis. Length of my petal is 4, so I go 1, 2, 3, 4. That's my first petal. And then I go the other direction, 1, 2, 3, 4. And there's my second petal. And that's it. That's my lemniscate. Doesn't matter how fat they are. They could be skinny, they could be chubby, I don't care. Okay, as long as you go out 4 in each direction. Done. Along your x-axis because it's cosine. Okay, so those are pretty simple. Sine lemniscate. Now yesterday, I know I said that almost all of the sine ones had y-axis symmetry. So you would think, oh, it's just the same thing along the y-axis. Yeah. Not true. So instead of having y-axis symmetry, it's going to still be a figure 8. But this time it's going to be along the line theta equals pi over 4. So it's along my 45-degree angle line. All right, so where is that? So right here. This is pi over 4. So this is going to be my axis of symmetry. Everything else is the same. So let's do an example. Let's do r squared equals 9 sine of 2 theta. Again, it's always 2 theta. This is sine this time. So a squared is 9, which means a is 3. That's the length of my petal. But it's along this axis, pi over 4. So again, I start at my pole, go out 3 in each direction, and then draw my figure 8. There's my lemniscate. Just the same thing. When it's negative, it just means it starts on the negative side and then goes around versus starting on the positive side and going around. So because it's r squared and your calculator automatically does r, you would have to take the square root of both sides to graph it on your calculator, and you'd have to do plus and minus. So you have to do the positive square root of 9 sine 2 theta, and then you'd also have to graph the negative square root of 9 sine 2 theta. Does that make sense? And it should work. It might be a little choppy, like it might not look like everything's connected, but it should give you an idea if you do both positive and negative. Okay? So lemniscates are actually kind of easier, I would say, even easier than the limosons, because you don't have so many rules to remember. Speaking of rules, the rose. All right, so it's time for the rose. This is the one with the most rules that you have to remember and walk through. Again, these are on your note card, but you do have to have them memorized for Monday's quiz. Monday is the quiz. Here's your patterns. The equations are of this format. Again, we're back to R equals. You're going to have a coefficient A, cosine, and then theta is going to have a coefficient N. So it could be a 2 theta, just like the lemniscate, or it could be a 3 theta or a 4 theta or a 5 theta or whatever kind of theta, okay? But if it has a coefficient there, that's kind of your first sign that, oh, this is a rose. If it has some coefficient besides 1, okay? Because the cardioids and the limosons, those were all just thetas, normal thetas. So anytime we get those are our roses. All right, so there's all these different rules for your rose. You first have to figure out where they start. Depending on if it's a cosine rose or a sine rose, they're going to start at different places. The cosine rose we all like better because it always just starts on the x-axis and you don't have to do any work. It's going to be nice and easy. It's going to start in the positive x-axis direction. That's your first petal. For the sine rose, you got to do a little work. It's not much. You just take 90 and divide it by n, whatever n is the coefficient of theta, and that gives you the first position for your sine rose. You have to figure out how many petals there are. Now this is a little tricky. It's not just straight up, right? If n is even, you have to double it. So if that n was 2 or 4 or 6 or 8, you would have to double it to get the number of petals. So if you've got a 2 here, it's actually going to be 4 petals. If you have a 4 here, it's going to be 8 petals. Get what I'm going with that? Okay. What if n is odd? Those are the easy ones. It's just n. So if there's a 3 theta or a 5 theta or a 7 theta, that is the number of petals. 3, 5, or 7. Okay? Double if it's even, just that same number if it's odd. Then you got to talk about how to space these petals out around the rose. They always have to be symmetric. They have to be evenly spaced. So the way you're going to do that is take 360 and divide it by the number of petals, which you just found in step 2. Once you have the spacing and where they start, then you can start placing all your petals around the rose. Let's try one. So cosine rose. Description. It's actually not even a rose. They don't look like roses. Like a rose would look like, right? They don't look like roses. I think they look more like daisies, to be honest. So I'm going to call it a daisy. But I don't really know much about flowers. Daisies are the white ones, right, with yellow in the middle? Yeah, this looks like a daisy. You'll see. All right, so here's our equation. Let's do this guy. R equals, I'll start with an easy one, 2 cosine of 3 theta. All right, so I see the 3 theta. I know, okay, there's a coefficient in front of theta. It's got to be a rose. It's not a lemniscate because it's not R squared. All right, so let's start. A equals 2. A is always, just like it was in the lemniscate, the length of my petal. So each of the petals are going to be a length of 2. 3 represents n. Okay? So let's go through our steps and let's start with start position. Start position is just the x-axis for the cosine. So I'm just going to be on my positive x-axis, a length of 2. So I start at my pole, length of 2, that's my first petal. For cosine, it's nice and easy, starts right on my x-axis. Okay, let's go to step 2. How many petals are there? Since n is odd, the number of petals is just n. So the number of petals is just 3. So I've already got 1 petal, so I need 2 more petals, but they have to be evenly placed around the circle. So I do my next step, which is spacing. So spacing now is 360 divided by the number of petals. That makes sense, right? So in this case, it's 360 divided by 3, which is 120. So my first petal was at 0. My next one needs to be 120 degrees from 0. And then my next one needs to be 120 degrees from there. And so I'm at 0, 120, and 240. So it's nice to just kind of list out where your petals are going to be. So then my next one I know is at 120. It still has a length of 2. And then my third one is at 240, and it still has a length of 2. And you see the symmetry there? Notice they're all 120 degrees apart, and they have x-axis symmetry because it's a cosine rose. And we're done. Kind of fun. It's a lot of steps, but if you just follow the steps that are listed up here, and you always go counterclockwise, they're not that bad. Should we try a sign one? All right, so our sign rose description now is going to be, again, a daisy. This is going to now have y-axis symmetry. Okay, the other one should have had x-axis symmetry, right? Right? It looks more like a daisy. I don't know. A daisy with 3 petals, though? That's weird. I don't know what that is. That looks more like a helicopter, a clover. I don't know, some kind of flower, right? Okay. A 3-leaf clover. Is that a lucky one? Let's try a harder one. Yeah? R equals 3 sine of 4 theta. So let's go through our steps. Start with start position. So where is this one going to start? Since it's a sine rose, I have to do 90 over n. Okay, so my starting is going to be 90 over n is 4. This is n, this is a, right? So 90 over 4, what's 90 divided by 4? Good, and yes, you can do that without a calculator, people. So my starting position is going to be at 22.5 degrees. What's the length of my petal? 3. So I'm going to start at 22.5 degrees. Well, this is 45, this is 30, so it's somewhere less than 30. And I have to be a length of 3 for my petal. So 1, 2, 3, maybe about here. That'd be about 22.5 degrees. Okay, so there's my first petal. I made these ones skinnier because I know there's going to be more of them. All right, that was step 1. Step 2, determine the number of petals. Is n even or odd? It's even. Since n equals 4, that's even. Therefore, number of petals is 2 times 4, which is 8. So I got to get 8 petals starting at 22.5, evenly spaced around the circle. So I got to do spacing next. Step 3, calculate the space. 360 divided by that number of petals, which was 8. What's 360 divided by 8? 45. So that's going to be my spacing between each of the petals. So I'm not going to start at 45. I already started at 22.5. But I start at 22.5, and then I have to add 45 degrees to get that spacing between my petals. So my next one would be at 67.5, and then I'd add another 45, right? And I'd be at 112.5, right? Then I'd add another 45, and I'd be at, all right, we can do all this. And add another 45. What's that, like 200 and something? 202? And add another 45. I got to get 8 of them. So 247.5. And then another 45 would be at what? 292.5? Is that right? Oh, I got to do one more. Plus another 45. 337.5. I think that's right. Again, you could just add 45 and add 45. You guys can all do that. Okay, so now let's place them. And again, these aren't going to be exact, right? So they need to be, what I'll check for is they need to be between the correct lines. So 67.5 has to be between 60 and 90, right? So I have to be somewhere here. And then 112 would be between 90 and 120. And then 157 would be between 150 and 180. And then it's really symmetry, right? So really all of these should be pretty symmetric. We're symmetric about the y-axis, but in this case it was actually symmetric about both the y-axis and the x-axis. Double check you've got 8 petals. Now that looks like a daisy, right? Too many petals? I don't know. That they're evenly spaced, and you are good to go.